voltage you are giving, you will keep at the y-axis. Your x-axis is changing with respect to time. So whatever, it can be square, rectangular, here it is sine wave. And then you may be in the exam, you can be also asked to show this way your input output. Okay, or you will be asked to plot the transfer curve. Transfer curve means x-axis is input, y-axis is output. Okay, so for negative this cycle, you will see that your output is following the input. Black is the input, blue is the output. Okay, so जैसा input है वैसा ही output है. So in case you will have this line, meaning that for whatever the input is on the x-axis, you will have the same output. Okay, that is one thing. This is for an ideal diode. Okay, and if it is 0.7 drop, then you take this way the line, little horizontal line, and then you draw this in parallel, skip parallel like this way. Right, so if it is 0.7, then up to 0.7 nothing. So this is the reverse bias thing. Okay, so this will remain as it is. But let's say that here 0.7, if you are considering, then you will be a little bit this way, and then you will draw like this. Okay, this in parallel, this is. Okay, and then this horizontal line. So let me just, so to consider this as yeah, so if it is an ideal one, then up to VR, okay, up to VR voltage, that is this voltage, right? That is here VR. If it is non-ideal 0.7 drop, then it is VR plus 0.7, then here, okay, it will be this way the line. So for an input up to VR voltage, so input is also varying from 0 to VR, the output will vary from 0 to VR. So up to some VR, okay, it is same. Okay, but after VR, for whatever the higher voltage it is, right? So you then this is the, let's say this VS is the peak. Then if this is the peak here, then it will remain whatever the VS is. Then it is this line and then this line, as you can see the black one here. So this is the transfer curve, and I hope you understand. This is very simple whatever I'm speaking. In fact, what I'm trying to explain you again and again. And similarly, if your diode is biased accordingly this way in the opposite polarity with this VR, then you will have this line as this, but this is for an ideal diode. If it is non-ideal diode, you will have up to 0.7, then a parallel line, and then this going up to VS. Do you understand now? So you can, if you are confused, always take some range. Okay, you can take some range that minus plus to minus plus minus 2 volt. Okay, and then 0.7, you do 0 to 2, 0 to 2, and then you plot. So with confidence you can do that. Do you understand?
Yes, ma'am.
Okay. And then similarly for this, if both are there in parallel and the connection is this way, as we had seen yesterday in detail, I had explained, then your transfer curve will be, this is for an ideal diode, and it is the kind of a transfer curve that you will have to draw. You have to be very careful where you are taking the output, R, L, C, whatever. So, okay, so with that note, so I was just to show the transfer curve, otherwise these things are same as what we had done this all yesterday. So there is another topic that is known as clamping or DC restoration. Now, what is DC restoration? Anybody has an idea? Clamping, as you can know, what is clamping? It is, clamping is nothing but you are changing the level of the signal. Okay. So the signal, as you can see here, if he with this voltage is that we looked. So here this was, let's say, 0 volt and some positive volt. Okay. So the signal was symmetrical to this 0 volt plus minus. But if this is not a 0 and this is 5, then we can say this is symmetrical to plus 5 volt, or it can be minus 5 instead of 0. Excuse me. So the signal can be having any, this is the DC component. So at any DC, it can have the DC component, and then it can be symmetrical to that. Okay. Now, if you can see here, what does it mean? As I had showed you here, right? To understand this, and this also you had understood. Sorry. Yeah, sorry. So this, right? So what was the goal of this VD here? I had explained you in detail. Who will tell me what is this circuit and this diagram speaking of? This circuit is behaving as what? Yeah, tell me. See, if you don't understand what has been done previously, you will not understand what we are doing now.
No,
Like
I
I am
think you
explaining.
told that to operate any diode, uh, first we have to means activate it by giving some forward potential, and then we use.
Very good. Very good. You are on track. So see now, two things you have to understand. That your diode application can be different applications. Okay. So one application is as a rectifier, that you are having 230 volt. Okay, and you just want positive full wave rectification or half wave rectification, and in that it is 230 volt or 100 volt, it is very high. In that case, it's okay when we are operating at very high voltage, because your diode is on, right? At 0.7 volt it will be on. So it's not a problem when you are, see, let me draw here and explain you once again, because if you see this, it is a simple topic, but you have to understand. Nobody understands properly. So I'm trying to do that. Uh, if you forget this signal, you forget now. So this is another application. But in your application, let's say this is a sine wave. Okay, this is a sine wave, which is minus 100 to plus 100 or minus 50 to plus 50. In that case, if you want to make this as a full wave rectifier, इसको हमको rectify करना है, this is 0, let's say. Okay, and you want to rectify, then this 0.7 drop is not a big deal, right? We can neglect that, and what you get at the output is uh, is the rectified signal of this, right? So if it is full wave, then you will get this kind of, right? And this is what, this will be still 0 and this will be 100. So 0.7 से कम होगा, if you to be more precise. ठीक है, लेकिन it is almost 100, so चलेगा. I mean, what I mean is, so 0.7 less than 100. So that is fine in that application. But your application is that you want to rectify input which is very low in millivolt. Okay, so it's a sign. So this is 0 to 100 volt. But I am talking of millivolt. अगर ये millivolt में होता plus minus 10 millivolt instead of plus minus 10 volt or 100 volt. So if it is millivolt and I directly give to the diode is off only. Diode is off up to 0.5 volt. So 0.1 volt, right? So 10 milli is 0.01 volt. Okay, 10 milli is 0.01 volt. It is off only. It cannot rectify. So that it can rectify this weak signal, which is very little. So when you take so first thing is you have to make the diode on. How do you make diode on? By giving a DC value. Okay, a DC component, that is, you make this 0.7 volt, then already this 0.7 it is operating, and to that you superimpose your little sine wave. So 0.7 volt it is already on. Onto this signal we will superimpose your little varying sine wave. And then accordingly, you get a linear distortion of the current, which will be further be, it will develop a voltage, right? There will be a load and it will develop a voltage and all those things. So further it will be propagated and this current will develop a voltage which is proportional to your input to this thing. So the point here is that you are giving a bias, you are giving energy, you are giving some voltage to make it work first. So do you understand two different applications? When it's already high voltage, you don't have to give bias. But now analog circuits are to process very weak signals. Okay, and diode application is rectification also, where you don't have to bias it. But when you are processing weak signals, which is usually the case, any embedded application you take, there are sensors, and the circuit is to process that. Okay, so that's what. So there, in that case, so and then you know about these two equations and this. So this is the operating point. So when we have a circuit like this, so when we have, so let's say VDD, okay, and to this you are superimposing, if there's a little you want to process sensor signal, then you will superimpose to this your little sine wave, okay. So then and then what you get is this kind of graphical representation. And when you have, so when it is so small, let us neglect that and try to study this and understand what is the operating point, right? So these are the two equations that the current will hold, right? One is whatever the current is flowing, it should satisfy both of these equations because it is flowing through this R and the same current is flowing. The point here is if you change R, I will change. Okay, this is very important. You understand now? I will change. Okay, and that change is within this diode. This diode curve is what this diode, wherever you use in the whole universe. Okay, in whichever circuit it is. कर्व तो ऐसा ही आएगा डायोड का, but it may operate at this voltage, or it may be operating at this voltage, or it may be operating on this voltage, depending on whether it is this current or this current. अगर ये current होगा तो ये voltage आएगा डायोड के across में, across the diode, this point and this point. If it is this current, it will operate at this voltage, and if it is this current, it will operate at this voltage. Okay, so this will be the little change. It is 0.7, this will be 0.73, this will be 0.76. And this current, ye current, it is depending on the value of VDD and R. If you change R, the current will change, and this operating voltage across the diode will change. Okay, so that is the thing. Now, if you want to see this graphically, it is this, and this is the operating point. Okay, so this is the current when you have a circuit like this, and this current is automatic. If you change R, current will change automatically. We don't have to go and intervene and change the current. This is how the nature works. करंट उतना ही फ्लो होगा जो दोनों इक्वेशन को सेटिस्फाई करेगा. दिस इज एन ऑटोमेटिक नेचुरल प्रोसेस. We don't have to go and change, and this is your operating point. So if you are given VDD and R, you can understand, you can, by using these two equations, two variables and two VD and ID, two equations, two variable, you can find out by equations also. And if you draw, we using these two things, if you draw the graph, this point is the one where you will find the voltage across the diode and the current that is flowing through the circuit, and this is the operating point. It can be the other way also, that you have a requirement कि इतना current pass होना चाहिए और इतना VD चाहिए. Okay, then accordingly you can set the value of VDD and R. Okay, so the design can be either way. I hope you understand. It is making sense to you. Okay, na?
Yes, ma'am.
Yeah, so that bias we were giving for the small signal is the DC bias. Okay, so this DC bias, in case of diode, it is simple to understand that for millivolt of signal, you are giving some DC voltage so that diode is operating and it can process a little signal which is in millivolt. Whenever you are using BJT, making an amplifier or filter or anything, all the circuits, they have a bias. Okay, and that is DC biasing, we say. So that is biasing, we say, and that is your DC signals we give to make your to give enough energy or operating conditions, that is in terms of voltage, to your signal so that it can be processed. So now what happens in your circuit? You know that there are n number of stages. For example, here what is shown is stage 1, 2, and 3. So what is the use of this circuit? Okay, this is known as clamping. Yani ki you are clamping or changing the level. Okay, or DC restoration. So this DC thing is very important. Here in this diagram, what I showed you was the DC part was here. This was DC. If it is zero point 0.7, this is your DC this is biasing, where you give a DC voltage, and that can be for any the this devices you will study further, BJT, MOSFET, all. Now what happens is that your circuits, the stages that I showed you here are 1, 2, 3 stages. Okay, that is shown here, stage 1, 2, 3, and these are the circuits which has BJT, RLC, diode. This can be other stage. Now when it is passing from one stage to other, if here it was 5 volt DC and the signal was symmetrical, once it is out and it is given to this stage, it will, the DC point from 5 volt, this DC, it will change to 0 volt from here. It may, so it, once it is moving from one state to other, the DC level changes. Okay, and when it is coming out here, it will be 0 volt. Now what is required is key, whatever the signal entered after processing, if the DC level needs to be same, that is 5 volt, but here you are getting 0 volt. So what we'll have to do, you will have to do a clamping, you will have to add a clamping circuit or a DC restoration circuit, which will again, जो भी enter हुआ था 5 volt DC component it was having. So this is the DC component, we say. Okay, and you will add an extra circuit after it is processed, because here the DC component was changed to 0. By adding a clamping circuit, you will restore whatever was the original, will be restored once you pass through this circuit, and it will restore the correct DC level. So that is the goal of this circuit, and the circuit looks like this. Okay, so this is a typical simple DC restoration circuit that can be added to get like this way the same DC component. So now you must understand that if this is the signal and you are restoring, so if this is the signal for which you are restoring, the nature of the signal should not change. If this is this wave, it should remain this. If it is this way, whatever, it should remain this way. So peak to peak should be same, the signal should be same. Only what changes is ये ऊपर नीचे जाएगा. So if this is a scale, let's say if this is from if this is 0 and this is -10, this is +10, and this is 0, and your signal is symmetrical, let's say to 0, and if you want to restore it to 10, then this whole thing should move to 10. Okay, so this whole thing, instead of 0 it will be 10, and this whole thing, same thing should move. So you copy the same thing and that should move, nothing else. Okay, so the same thing should move. Okay, I didn't copy, but the same thing should move. So there should not be any change in the signal. The peak to peak should also remain same. Only that the DC component, it was 0. If I want to make it to 10 or -10, up, down, जो भी जाएगा, ऊपर नीचे जाएगा, but the signal will remain same. It has to be preserved. Okay, so that's what the circuit does, and this is a typical such circuit. Now, how does it work? So let's say that this is now, a square wave, which is symmetrical to 0. Okay, and let's say that this is plus, this is -1, and this is +1, let's say. -1 and +1. And you want to have this to be, so now this is 0 DC component, you want it at -1. Okay, for example. So if it is if the DC component is -1, then this we should come here, right? This it should come down. Well, so your signal should be like this then. Okay, and it will be symmetrical to -1, and that way it can go up also, whatever, -2, -3, whatever you want. So for that, what you will do, this is the simple circuit. where this is capacitor here and the diode here. The input is here across these two terminal, and the output is across the diode. Okay, and if my this is my input for this circuit, now you see the polarity of the diode. So the direction of the current is this. Okay, current is flowing this way. And this is what plus of the diode, this is minus of the diode. And as I said to you in the beginning, that to analyze this kind of circuit where this is the input, you will divide into two things. First is for the positive half and then for the negative half. So for the positive half, if you are giving this as an input, right? And so this is plus, let's say this is minus. Okay, and this is minus and this is plus of the diode. So during positive half of the signal, are you understanding now whatever I'm speaking?
Yes.
Yes, ma'am.
Yeah, so during positive half of the signal now, this is plus, this is minus, you agree? This is plus of the diode, this is minus of the diode, that is universally accepted. This diode will be forward biased or reverse biased. Consider ideal diode.
Forward bias.
Forward bias.
फॉरवर्ड बायस. ओके, वेरी गुड. सो अगर फॉरवर्ड बायस है तो ये क्या होगा, शॉर्ट हो जाएगा कि नहीं?
Yes,
You
ma'am.
can think na short, yes. So now always understand, if these circuits are drawn this way, you have to understand that there is a ground here. Ground to hai hi. It may not be shown. So this is grounded. So now once it is shorted, the current is getting a path to flow. क्योंकि इधर से the battery and then there is a ground. Open नहीं है, there is a ground here. It is getting a path to flow. Now this is the direction of the flow of the current, because the polarity of the diode you can understand. And this is plus, this is minus. So what will happen? The current is flowing this way, okay, and going this way. So now this is plus. So when the current is flowing this way, then there is a capacitor here. This will be plus and this will be minus. And the capacitor will charge to the maximum. If this is 1 volt, it will charge to 1 volt. Do you understand? If this is 2 volt, it will charge to 2 volt. Okay, nahi? Capacitor
Yes,
charge.
ma'am.
So now the capacitor has charged, let's say whatever this maximum voltage is. If it is 2 volt, 1 volt, 0.5 volt, it has charged. This is, let's say, X. Then the capacitor has charged to X volt. Now comes negative half. How second negative half?
Yes, sir.
Yeah. So now when it is a negative half, it will be minus and plus here. So diode will be what? Forward biased or reverse biased?
Reverse biased.
Reverse.
Very good. So now diode is reverse biased. Already your capacitor was charged here. Your capacitor was charged to X. Okay, and now the output is where? Here. You are measuring the voltage here. So now, so now this is plus minus. Okay, X. Okay, plus minus of X. Okay or no? A minus plus and negative એટલે. So this plus here, minus here. This was charged with this polarity. So the voltage here, this is equal to, if you write down a loop equation, then this voltage is equal to
2x.
This voltage, if you write down a loop equation of the voltages, then
Minus.
so it is switched off. This is open. This is plus minus, and then this is plus minus. So it will add up now. Plus minus add up. These two voltages will add up, and this is equal to minus of this plus this. So these two will add up. है कि नहीं?
Yes, ma'am.
Now,
Yes,
if
ma'am.
I have the loop equation, then this is equal to minus of this plus this. And now this was already x, this is x, so this is 2x, and this is equal to minus of 2x. So the thing is that when it was conducting, when this guy was charging, the output here was 0 for all the positive half. So for all the positive half, it was 0. And for the negative half, when it was there, then the output here was twice negative. So, so if this is x, this is minus x, then this is 0 and this is 2x. Now, if there is a battery there, okay, so the diode is still this way. You can have the other way also. What will happen, I'll show you. But now the diode is here and I'm having a battery with this polarity, or it can be this polarity also. So first of all, what you will do when you are given such a circuit and you are given an input and asked to draw an output, what you will do first thing is that you just think that first of all this is not there. Okay, so if with this not there and if this is the input, then this will be symmetrical as you have just seen to this. Now what you see here is then you have to see the polarity of the battery. Okay, so this battery polarity is what? Here it is plus and minus. So jab bhi plus hai, so whatever it is. So let's say that this is minus 5 to plus 5. Okay, so this is minus 5, this is plus 5. Okay, and this is 1 volt. Okay, so initially it will be what? 0. And then this will be what? If this is plus 5 and this is minus 5, what is peak to peak?
10.
10. So આ 0 હોય તો અહીંયા શું આવશે? minus 10 આવશે કે નહીં?
Yes.
Yes,
This
ma'am.
is 0, then this will be minus 10. Okay, minus 10. So that if without battery, this will be the ideal thing. But a battery have 1 volt છે. So what you will do, peak to peak will remain same. So if it is, this is positive 1 volt, એટલે આ 0 થી ઉપર જવાનું પછી આપણે. અને અહીંયા 1 volt થશે તો આ 9 થઈ જશે. That's it. So this is the thing. Now you can see other thing. This is pointing downward. If you see બહુ time in case of you are by practice, and now I'm giving you a trick, you can do things fast. You don't have to think so much and waste your time. So if this arrow is going down, it means that if this is symmetrical to this 0, then this will go down, and then from this 0 will be the maximum, and your minimum will be whatever the peak is, right? Negative of that. So here it is down, means this whole waveform is going, this is down, this waveform is going down, maximum is 0, that way. And if this is positive, then you move that much up, and you minus from this lower that much. So peak to peak should be same, okay, with your original waveform. Now this is minus, you see, if this is minus, you go that much down again. Minus 1 હોય, right? So this will be, then you go move the whole waveform. This will be minus 1, this will be minus 11 then. So minus 1 minus of minus 11 is, then peak to peak is 10 volt, that way. And then similarly, if this is up and this is positive battery, now this is up. So the first thing is, when it is up, it will be symmetrical to your lowest will be at 0. Okay, but as it will, let's say this is 1 volt, then that lower thing will go to that 1 volt. Okay, it will move that much up, and your up, the maximum will also move that much up. So then you move that much up. If here it is minus, then this is up. So whole thing with the 0, you make it first. Okay, and then if it is minus, so it will need to just પછી. Okay, so if it is minus 1, if it is plus minus 5 volt, right, then this will be 10 volt initially if there is no battery, and this minimum is 0 volt. But if there is a battery and this is minus 1, then this will be minus 1 and this will be plus 9. So the whole waveform will go up, and whatever is this, so પાછું એટલું ઊંચું નીચું થશે waveform. Do you understand?
Yes.
Okay. So be prepared for such questions in the exam. Now, see, this is the circuit that we just saw. Okay, and what happens is that there is a load. So, so this is DC restoration, and here, 1 minute. Yeah. So, so this I'll explain you shortly. So this is the same thing that is explained here. If this is up, pointing up, then the current will flow in this direction. Okay, so a negative. So this is what, plus, this is minus. So when this is minus and here it is plus, so for the negative cycle, this will be forward biased. Okay, the other way. And the current that is flowing ICC dVc upon dt. And here this Vs is equal to this plus this, right? So that implies that this V0 is equal to Vs minus Vc. Okay, so this is Vs minus Vc, and then that Vc is already it will be, so if this is negative in the negative cycle, when the current is flowing, this potential will be minus, and then here it will be plus that way. And there are positive cycle also, that is plus and minus. At that time, right? At that time, what will happen? This is open, right? And the voltage will add up. So this is positive and minus of this. The minus of minus is plus. So that way you will get V0, which is addition of both. So here, for this, right? So when it was minus, this are minus, there are minus plus or there are charge 3. So this was minus 6. So this is 6 volt with this polarity, minus and plus. And then you have plus 4. So plus 4 is coming here. Okay, so your V0 is equal to this Vs, that is 4, and minus of minus 6 is 10. So peak to peak, it will be your 10. So without any this battery here, if this is minus 6 and this is plus 4, your minimum will be at 0 and maximum will be at 10. And your battery has it, accordingly, it will, if it is positive polarity, it will go that much still up, right? And otherwise, little down, the other polarity. So, right, so it is open. So this is the same thing explained again and again. At the beginning, the diode is a short, right? And C will charge up to the most negative peak. Same thing, minus 6. And this, the diode was shorted. And because it is short, V0 is 0. Right? And at this point, and then when there is a positive cycle, the diode is open and the capacitor will retain the voltage. Whatever can be open. And this is what? So 4 minus minus 6 is 10 volt. And but in reality, what happens? There is a load. This thing is given to the next stage. There is a circuit which can be represented by the input impedance, okay, or input resistance, which is equal to R. So what happens is that when this was charged, and then in the later cycle, this was open. So when this was open at that time in this stage, what we saw is that this didn't get a path to discharge. But in practical circuits, this output is given as an input to the next stage, which is here denoted by 1 R only. We are bringing down the whole circuit, which is followed by this to the input resistance. So that is this R. So when this is open, this will get time to discharge. Okay. So actually your waveform will be, it will not be a straight line, it will be little bit discharged like this way. And here also like this. So this is discharging, this is charging. And that's what is happening. And what if to prevent this capacitor to discharge, what we want is that your RC time constant should be very, very greater than the time period of this circuit, of this. So this is the time period, right? So from this point to this point is your T. So this T should be, or T by 2 should be very, very less than RC. This time constant should be very, very greater, because this R into C is time it takes to discharge, okay? And that should be very, very greater, because it should only discharge little, then and then you will get almost horizontal. You can preserve the nature of the waveform, right? So that's very necessary. Okay, so is that clear? Now this is a problem here that I need you need to understand very well, and it may take 10-15 minutes and you can expect this kind of question in the exam. So I'll end up with this two problem, and I have to explain you properly. In this example, you can see some R and voltage is given, and D1 and D2 are two diodes. What is asked to you is to find out I and V. Can you see, everybody? I asked you, can you see? Only that much simple question.
Yes.
Yes, sir.
Yeah. So now if you have to find now there are two diodes. There can be three diodes. And then how will you find out I and V? Because to find out I and V, at least you should know whether it is conducting or not. And like a forward bias state, reverse bias state. That much we should know, no? Then you can say that, okay, this will be I or V. Do you understand my point?
Yes, ma'am.
Because a diode is either conducting or not conducting. There are two states, forward bias or reverse bias, and there are two diodes. So what is the possibility? Both are not conducting, or either one is conducting. So that is two possibility, and both are conducting. So out of these four possibilities, just looking to this, you will not know. And if you don't know whether they are conducting or not conducting, how will you find out I and V? So as an engineer, what we do is we suppose, because we don't know out of four conditions. And if both are not conducting, means the circuit is dead. We don't need to do anything. So you are left with three suppositions. Either of them is conducting is two supposition. So D1 is conducting, D2 is off, and vice versa. Two supposition, both are conducting. And with that supposition, you find out I and V. So here you can do two things, especially if you find out the I, the direction, you know where is I now here. Be very attentive. You know where is I here. This is I, and this is V. So you find out I, and if you get the correct polarity, okay. So if the diode is connected this way, then the current is flowing this way. Okay, and if you get I positive, that means that this polarity is correct. That means the diode connected this way is correct. Then your supposition is correct. Because the electronics is all about I and V. And if you can manage to find out the direction of the current, if your answer is positive, that means your assumption is correct. Positive means whatever the direction or the polarity you assumed is correct. And if your current comes negative, that means that the current should be flowing this way. Hence, the direction, the diode must be connected the other way, right? Because if you are getting a negative current, that means whatever the connections are now, you have to flip it. Okay, so and the diode connection will be the other way. So the supposition you made was wrong, and you resuppose the options that are left. Okay, so do you understand what I mean? Will do, so that you will understand. થોડુંક તો સમજાણું ને?
Yes,
Literally,
ma'am.
Yes,
Yes.
okay. So with that thing, you can suppose anything, and let us suppose first thing that both are conducting. Okay, we'll give chance to both as conducting, and we'll take another example also, so things will be more clear. So now with both of them conducting, right? What will happen if both are conducting? Right, then this will be short, and this will be also short. We are supposing, we don't know. From the answer we get, we will find out whether our supposition is correct. And the answer is what? Finding I and V. And I જો બરાબર direction મળશે તો our supposition is correct. When direction ઊંધી હશે તો our supposition is wrong. If I direction is negative, it means that this has to be flipped. But this is this way, so our supposition was wrong, and we resuppose. So if both are conducting, a short છે કે નથી?
Yes, ma'am.
Very good. So if this is short, then this point is what? Grounded?
Yes, ma'am. 0 volt.
0 volt. So then this point will be?
Will be V.
Also 0.
Zero,
Zero.
ne? So V will be what?
Zero.
Zero.
0 volt. Very good. So then we can find out I, because now this is the node here, and you have ID2 coming here. You have, so this is 0. Now we have figured out our voltage 0. We have I coming here, this ID2 coming here, and this is the this. So this plus this is this or no?
Yes, ma'am.
Current plus this
Yes, ma'am.
current.
Equal to 1 milliamp.
This is connected this way, this is connected this way. તો આ તો બે આમ જ આવવાના છે અને આને આમ જ નાખવું પડે. So now what will be your ID2? 10 ID2.
2 milliampere.
2 milliamp.
Very good. 10 minus 0 divided by 5 is 2 milli. And how about this? I find
Minus
Karan.
It will be minus
Yeah,
1.
you have to find out
Minus
this.
1.
It will be minus 1.
So you have to find out this. So this is 0 minus minus 10 divided by this. Okay. So how much is this?
1 milliamp.
1 million.
1 milliamp. So 1
One.
milliamp is equal to this plus this.
I plus ID2.
So I is equal to what?
Minus 1 milliampere.
Minus 1 I would. Now minus 1 means what? The direction will be this now. If it is positive, this is the correct direction. But minus means our direction ma hovu જોઈએ. So if the current is this direction, the diode also has to be flipped, na?
Yes, so assumption is wrong.
Yes, ma'am.
So our assumption is wrong, and we will reassume. Now you can reassume now that D1 is on and D2 is off, and vice versa. So now you can assume anything, and now let us assume that D1 is off and D2 is on. વાંધો નથી ને તમને?
No.
Very good. So now if you assume that, then what? Huh?
Hello, ma'am.
So this is on, this is off. તો આ તો કટ થઈ ગયું.
Then
Hello,
will be I is
Just
equal
tell me please. બોલ.
Shouldn't be the ground and the point B are at the same potential, so I will be 0.
એની સમજી નહીં.
Ground and B are at the same potential, point B. If we consider that D1 and D2 both are in forward bias, then ground and point B are at the same potential, so I will be 0. So we can consider that ID2 is like 10 minus 10 upon 15 kilo ohm.
This you have to find out.
Yeah, I will be 0 because
D1 is off, no?
yes, ma'am.
it is like short circuit. So point B and ground are at the same potential. So no current will flow in that network. So ID2 is like 10 minus 10 divided by 15 kilo ohm. The whole path. V will be 0.
So this so this is on.
So I'm talking about the
On
previous case that we
On
considered.
ક્યારે કહેવાય? Our supposition. See, by practice you will know that okay, on છે, off છે. But you are initially you are doing, you don't know what it is. So you will suppose on means what current is flowing. જો તને ખબર જ પડી ગઈ, તું આપણે એટલા સ્માર્ટ છે તો તું સીધું કરે તો તને જોઈને that comes by practice. What you are telling is correct, but you don't know. That comes by practice. અહીંયા માનને કે વોલ્ટેજ આપ્યું છે, ચલો. Okay, so અહીંયા +1 આપ્યું છે, let's say.
Then B will, if
I
you,
mean, irrespective of looking to the voltages, that will, whatever you are telling will come by practice. કે જોઈને પછી ખબર પડી જશે કે okay, are not possible. When you say on, means this is conducting. Okay. So blindly, if you are doing, you don't know, and not thinking other next steps, jaldi calculations mind ma nathi kari leta, and you are just supposing and then moving slowly, then that's what I showed you. Now whatever you are telling is correct. Now we'll suppose that only, and then only it will come. પણ માન કે આ એક વોલ્ટેજ છે, ઇમિડિયેટલી ખબર નથી પડી આપણને. આ તો ઝીરો છે એટલે બ્લેક એન્ડ વ્હાઈટ થઈ ગયું કે ભાઈ ઝીરો ઝીરો છે અને જલ્દી તે માઇન્ડમાં કેલ્ક્યુલેશન કરી લીધું. Okay, but as a beginner, this will be the approach. That's what I'm telling you.
Okay, ma'am.
So now you are right. પણ that comes by practice. કે પછી તને જલ્દી જલ્દી ખબર પડી જ જાય and then you will say no આનું આમ જ હોય. આપણે કેમ trigonometry, you will do integration in mind and say okay this is the final thing એવું. પણ initially you don't know અહીંયા કંઈક voltage હોય આપ્યું હોય તો then it will be difficult. Let's say for example this also can be a voltage given. You'll see in the next example. બરાબર છે તો એમાં so if this is some so that whatever we suppose is so both these examples you will understand, but as I said you are right if you can do it that way. So અહીંયા જે suppose કર્યું okay એક minute. So now we suppose the other way and then what, right? So that's what. So this was not possible and we'll assume that D1 is off and D2 is on, right? And then in that case, so if this is off, right, D1 is off. So then this segment is not there. A cut થઈ ગઈ segment. This is open. And what you are left is this 10 current flowing ID2 is 10 minus of minus 10 divided by this 5 plus 10. So ID2 is 1.33. This is already 0. And VB, this is this voltage now that you have to find out. You know the current that is flowing, same current will flow, right? So it is minus 10 plus the current is 1.33 into this 10. So that is 3.3 volts. So I is 0 and this is this. So what you are telling is by experience it will come slowly. But અહીંયા કંઈક વોલ્ટેજ હું કહું કે ભાઈ અહીંયા -+2 છે તો બરાબર 0 હતું એટલે બ્લેક એન્ડ વ્હાઈટ થઈ ગયું કે you are right. But this +2, so without knowing this you can't say it directly. આ 0 હતું એટલે બરાબર છે, આ 0 આવી ગયું. So you have to go step by step. That's the point. Sorry, where was I? 1 minute, huh? Let me discard all this. Can shoot you. Yeah. So, yeah, this is another example. So this is what, and then this is not possible, right? So D1 is off and D2 is on. And in that case, this is off, this is not there. And this is your ID2. 1 minute, what the mix થઈ ગયું છે. See, in one it is 10 volt here and minus 10 volt here. And this 5 here and 10 here. In another example, અહીંયા 10 છે અને અહીંયા 5 છે. In another example, it is 5 here and 10 here. And here it was 2. So both the diodes are conducting. That is what we supposed. So this is 0 and hence this will be also 0 as we just talked, right? And then ID2, so this is the current that is flowing. And so this ID2 is, so this is 0 now. So that's why ID2 is 1 milli as we just discussed. And this current plus this current, 1 ID2 plus I is equal to this current. And I is 1 milliamp. Okay, results in I is equal to 1 milliamp. So this is in the positive direction, whatever you are getting, right? I is positive. So whatever, so this is correct direction because it is, your answer is positive. and that means that the diode that it is the connection that it is making anode cathode is also correct, and whatever you have assumed is also correct, right? With that, I will be 1 milli and V will be 0, as we just did it. And in another case, it is this way. So you assume both are conducting, correct? And then you will end up that it is not possible. In this case, it was possible. In this case, it is not possible because 5 and 10 here. And that's why you will say this is off and this is on. So even if you change a little bit now, things will change. And so here I is 0 and V is this much. And in the other case, it was I was there and V was 0. So both are conducting in this case because the current you got is 1 milli correctly.
Hello, ma'am.
हाँ बोलो. Not to be confused, you blindly suppose first and then you say both are on and then you go ahead. Even if you are very strong, you go do it by pen and paper. हाँ बोलो, please.
Yes, ma'am. Ma'am, we can also assume D1 to be off and D2 to be on in the second case as well.
Yeah. You can assume out of 4 anything. First step. If you
Yeah,
do,
but that is also a legal circuit, and we get another voltage.
okay, which you want to do for this one? You want to suppose?
Yes, in the
Animated
second case.
second case, okay.
No,
So
this is
here,
not this. Another one.
this is the second case. This is the first one. આ પહેલું છે. See, 5 and 10 here is the first. Sorry, the 10 and 5 is the case first.
Yeah,
and
in this case.
okay. So you suppose
Yes,
that this is conducting and this is not conducting. You suppose that. So if this is not
Yes.
conducting, this is not conducting, then you cross it. This is open.
Yeah, so this circuit is also legal. So we get a different voltage this time.
But you have to find out I now here. You cannot from the beginning say I is 0. We don't know. You cannot say I is 0. પહેલેથી જ તું 0 assume કરી લે તો પછી find શું કરો?
No, ma'am, I am saying that what if we assume D1 to be off and D2 to be
Here
on?
I is passing through D1. And in your assumption, you are telling that this is conducting and this is not conducting. Now, if this is not conducting, you are already killing I. It is 0. So, wow. Okay, then you do go ahead and just check it out. We can check it out. So, I is 0 in that case. Then you find out V. If I is 0, and then you find out ID2 and V. Right? ID2
Yes,
and V. Find
in
out.
this case as well, ID2 is positive and V is.
Now calculate and tell me then, and find out V also. You do pencil paper work so that with polarity or anything you are not mistaken. We can discuss in the next lecture. Everybody can do that homework, and you do that. I am requesting, and you show, you prove that your supposition is wrong, either with the polarity of ID2 or V. You do that pen paper work.
Hello, ma'am.
हाँ.
In this circuit, वो तो मतलब इसमें देखो लेफ्ट में वो बी का पोटेंशियल 0 होगा ना?
B will be 0. No, how? Now see, this segment is, if this is not conducting, this segment is
नहीं,
not.
in this both the diodes are conducting.
આને શોર્ટ કરી દો, conduct કરવું છે તો.
In this example I was saying, ma'am.
આ જ example માં
If D1 is short circuited,
What do you
D1
want
is
to
not
suppose? What do you want to suppose? D1 on के off?
D1 in इसमें लिखा ही है both are conducting.
Then if D1 is conducting,
So
then આ short થઈ ગયું.
B
If whatever you want to suppose, you suppose. Now you
no,
want to suppose
as
that
the
this is
previous
conducting.
Ritik
આ short
pointed
થઈ
out.
ગયું. હેલો આ conduct કરે તો short કહેવાય કે ના કહેવાય? હેલો ક્યાં ગયું? હેલો, am I connected or no?
Yes, ma'am.
Hello,
You are connected.
Yes, ma'am, you are audible. You
am
are
I
audible.
connected or lost my connection? Okay, okay, I'm coming to this boy who wants this diode to be conducting. If this
Hello.
is conducting, the short kevai ke nahi? Am I audible to you? Am I
In
audible
between
to
you are
you?
not, ma'am. Yes, now
Okay,
you are.
1 minute. Let me change my. Okay, or let me. If still not, then I'll have to change my internet connection. Am I audible still?
Yes, ma'am.
Yes,
With
ma'am,
my-
you are audible.
To everybody, I'm audible or?
Yes, ma'am, you are audible.
Okay. See, if this is conducting, then there is no question. If it is conducting, this point and this point are same. अगर आ ग्राउंड है तो आ पर ग्राउंड था सर. Okay, conducting હોય તો.
Yes, ma'am.
No conducting હોય તો this is open. This is like this segment is not there. And what is alive is only this part. Okay. And then from
Yes,
that
ma'am.
you find out V and the polarity of that or whatever, and then you figure out with correct minus plus. Okay, let us go to the next example. You give a thought, you do that exercise, and as one of your colleagues said, you take this guy D1 as not conducting and this as conducting. You suppose that way. Okay, and
Ma'am, I
then
did it, ma'am. I did it,
okay.
and V was coming out to be negative, so it was my fault. Sorry, ma'am.
No, it is not your fault. That's what I said, that if you suppose something wrong, then you will not get the correct polarity. Okay, and then you have to resuppose. That's the only option. And you can resuppose so that D2 is off and D1 is on also. And then you will find wrong with the polarity of I. Then you suppose both are conducting because two things we have done, you didn't get it. So the only third option is left. But make sure you do correctly the steps with pen and paper and pencil. Sometimes we try to jump, but ये plus minus में ये कभी mistake हो जाता है. So if you don't mind, shall I end with this or because 2 o'clock you will have a lab, let me tell you, your other lab will start from 4 to 5. The lab, sorry, you have 2 to 5 lab. Hardware, your lab, analog lab through camera and components and all, the instruments, everything we will show you from 4 to 5. So for that, I am going to share in our group another link. And 2 to 4, you will do your normal LT Spice exercise. And I don't want any argument in drawing this graph. Whatever you see in LT Spice, you just draw it, x-axis kiya, y-axis kiya, right? You write down in units of 10, 10, 10 milli, 20 milli, 30 milli, and you draw the graph. It's not that you will get an award for the precision of whatever you are drawing in your. It has to be similar, okay? Not same to same. So you draw, you may have to come to the institute and you will be graded. If it is written neatly, clearly, all the steps, you will get full marks and nobody should get less than 30 marks, 30 out of 30 in lab at least. So, so don't argue in that. This is all for you only. And to 4 to 5, we will show you the hardware thing. And I'll share the link separate for that. Otherwise, you have to use your normal link of your group. Although you are free to be mobile. You can go and see the other group if you want, or talk to your friend, but that cannot be entertained for a long time. If it is something technical only, you do that. Okay. I will see you Friday then. Thank you.
Yeah.
अरे क्या है